Um, Hello, and thank you for joining our Solenis Insights about discovering hidden process dynamics by combining artificial intelligence with paper-making process knowledge. I am Beth Ann Zarko, product marketer for Solenis's digital solutions, and I will be your facilitator for today's meeting. I would like to thank you all for joining us today. Before we get started, I'd like to cover some housekeeping items. Please keep your lines muted during the presentation. We will have about 10 to 15 minutes for Q&A following the presentation. And at that time, you can unmute your line to ask a question or just type the question in the chat window. You can open the chat panel by clicking the message icon on the toolbar at the lower part of your screen. If you have a question during the presentation, you're welcome to type it in the chat window or use the raise hand icon, which is also on that lower toolbar. This webinar is being recorded and a copy will be shared on solenis.com. Allow me to introduce our speakers. Paul Valek is the General Manager and Global Marketing Leader for Predictive Analytics. Paul leads the overall strategic direction and commercial deployment of, of OPTIX Applied Intelligence platform. Paul has over 25 years of finance, commercial, product management, Six Sigma, and strategic marketing experience, and holds a Bachelor's of Science in Finance from Michigan State University in East Lansing, Michigan. Also with us today is Tony Lewis, the Global Product Manager for Digital Solutions, with more than 23 years of paper experience. Tony leads the product development team for the OPTIX Applied Intelligence platform and other advanced analytics developments. Tony holds a Bachelor's of Science in Paper Science Engineering from SUNY College of Environmental Science and Forestry in Syracuse, New York, and a MBA from Eastern University in Philadelphia, Pennsylvania. He is a certified Agile practitioner. Paul and Tony will take us through an introduction of OPTIX, a live demonstration of the product, and examples of OPTIX in practice. At this time, I'll hand it over to Paul.
Great. Thank you, Beth Ann. It's great to be here and extending a warm and safe welcome to all of our friends across Europe, Asia, Middle East, and Africa. As Beth Ann said, I'm the general manager of the analytics team. What I'm going to cover today are, for those of you that may be new to Solenis, just a brief introduction of who Solenis is. Number two is some of the dynamics that are impacting our industry and local mills to support and drive a need for advanced analytics, a brief introduction of what OPTIX is, and then I'll turn it over to Tony, and Tony will actually conduct the live demonstration to give you a real firsthand feel of how to use the application. So again, if you don't know who Solenis is, we are a leading specialty provider in the pulp and paper industry, as well as other large, heavy industry sectors around the globe. Our expertise and experience is built over 100 years of experience through some of the best service and chemical suppliers in this industry. And we continue to add to our portfolio yearly. We're supported by over 5,200 employees, of which a significant portion are in the field. This is how we bring our chemistry and apply our chemistry through the 1,300 field and service representatives across the globe, serving customers like yourself in over 120 countries around the globe. And again, supported by just a world-class supply chain, bringing our solutions as close to the customers as possible, with 39 manufacturing facilities, 4 R&D labs, and 11 application centers. So what is the pulp and paper industry dealing today? What are the challenges that we deal with every morning that we wake up? Number one is our mills are becoming more complex. Machines are getting more complex because of the demands on the industry. Because of that, the industry has started to invest in data and analytics strategies, consolidating data historians, linking data historians from one mill to another, incorporating advanced sensors across the machine. So that's a representation that in order to continue to extract as much value and productivity out of paper machines, we have to invest in technology. At the same time, employees in the mill are becoming more comfortable with that technology and are being expected to utilize these technologies again to extract as much value as possible. While this is happening on a personnel perspective, using these new solutions not only helps to attract young talent, right? Young talent wants to go and work for companies that are employing the latest tools. So the more Solenis, the more our customers are employing these tools, we just become more attractive to the next set of leaders in our companies. And with a lot of retirements, people in the mills retiring, we need to supplement that loss of expertise, that loss of personnel with different tools and different approaches. Then when we come down to artificial intelligence, it is becoming more understood. Costs are coming down. Mills are starting to incorporate it into their processes. And then obviously, what are everybody dealing with around the globe today is COVID. And what COVID and Corona is really doing is it's accelerating manufacturing's drive to do more with data, to understand more of their processes. It's driving a path towards more autonomous and remote operations and monitoring. And so at the end of the day, our world is changing very quickly. The good news is a solution exists, and this is what we'll cover today with OPTIX. Not only are there macro dynamics impacting our industry, but at the local mill level, what's happening? Well, all of that data is being generated, through these new solutions, through sensors, through these data historians, right? So there's a wealth of data that if the mills could just efficiently and effectively use, they would be able to do more. However, that data is very complex. It comes from a highly variable and continuous process. And because it's highly variable, it comes from a continuous process. Nothing gets more complex than paper making, right? You need a set of tools that actually reflect the complexities of that environment. What our customers are asking for is great. I have all this data. I understand the process more. Now tell me why things are actually happening, right? Because today, a lot of our customers are still fairly blind, meaning they don't have full visibility to what's going on in their process, yet they're still trying to make decisions, right? So not only do we have these dynamics happening at the industry level, those are absolutely reflected in what's going on at the mill level. And an example of that is this page here, where today when process engineers and others go and start to approach investigate an issue, we typically, because of the limitations of the tools available today, we tend to look at it more of a linear correlation, right? On this example, basis weight, as we know, basis rate and strength are fairly linearly correlated, right? And so when you start to go and map it and use some of the statistical tools available today, that only gets you so far. Why does it only get you so far? Is because in reality, paper making is not a straight line. It's not just two variables that are linearly correlated, right? And it goes in a straight line. Paper making is much more complex. You actually have hundreds of relationships, or can have hundreds of relationships between these different dynamics, these different process inputs and variables. Sometimes those relationships are linear, sometimes they're not. Sometimes they're present and strong, sometimes they're weak or non-existent. And this is always constantly changing, right? And these dynamics are different on one machine versus the machine that sits right next to it. So as we were looking to help our customers, we realized that the approach on the left-hand side is no longer accurate, is no longer adequate, because it doesn't reflect the true underlying nature and characteristics of the process. And as our customers expect more optimization and more productivity, we needed a solution that could address the right-hand side of the page to meet those customers' expectations. So what is OPTIX? How is it built? And then I'll talk about, in very simple terms, what kind of value does it deliver? How should you think about OPTIX? So first of all, OPTIX is a cloud-based platform. The reason it's hosted in the cloud is because it takes that much computing power to do the complex math needed to address the right-hand side of that previous page. This cannot be done locally. It cannot be done on, but in order to be as effective, it needs to rely on all that cloud computing power. Something sitting just on a desktop or a simple software package, again, does not have the analytical robustness, does not have the computing power to perform the complex calculations needed to extract as much value as possible. So that infrastructure incorporates a couple things. Obviously, what's going on the machine today, those are absolutely critical inputs. But what differentiates Solenis's approach is we take what's going on in the process, we combine that with our domain expertise, right? So there's lots of solutions in the market, but they tend to come from a different industry, or they're implemented by a consulting or a software company or a technology company, and those entities do not understand papermaking. And in order to effectively understand, create, deploy, and work with paper mills around the world, you have to be able to understand how paper is made, the challenges, the language in which we speak in this industry, in order to effectively, again, develop, implement, and deploy these solutions. Obviously, we do this with real-time process data, with the lab measurements, to really do a couple things. To provide a real-time predictive soft sensor supported by an advanced analytics platform. And this really creates capabilities that weren't previously accessible to the industry. What are those capabilities? So when you think about OPTIX, and it'll become evident when Tony goes through the demonstration, is we'd like you to think about OPTIX really in 3 different value domains. The first one, and the first functionality, is instead of waiting 45 minutes to get that quality lab test, whether it's around strength on paper, whether it's around brightness or kappa in pulp, right, is we can now provide those quality measurements, not in 45 minutes or longer based on a lab test, but every 30 seconds. And that real-time quality prediction available to the operators now enables a real-time response. So again, instead of making a change on the machine every 45 minutes, and we know a lot of paper can be made in that period of time, by having those quality measurements every 30 seconds, those operators in the mill can now have a real-time response and mitigate things drifting away from target. So that's number one. Number two is, because of the advanced analytics that this platform delivers, we now can bring visibility to the key influencers, the key dominant variables that are driving the prediction, which then gives new process insights to process engineers, mill technology teams, etc., to understand more about what's driving the process. And then third, what we're able to do is, because we understand the process more, because we are getting real-time quality inputs, now we can control some of the most important inputs into the process and do it autonomously and do it in real time. So now we have the capability of, in real time, immediately controlling process inputs like chemistry, potentially Furnish, right? And so if we can do that in real time, we minimize waste, we optimize those processes, and in today's economic environment, where you guys are trying to squeeze every dollar you can and probably do it with less personnel than before, right? To be able to do that in an autonomous, real-time fashion is hugely important. So again, think about OPTIX in being able to provide a real-time response, have new process insights in regards to what's going on that machine, and then 3, enable immediate input optimization. So what do different solutions look like from different suppliers? The intent of this slide is not to do a compare and a contrast of Solenis to alternatives, but really what I'd like to use this chart is to ask you guys to think about how would you evaluate a solution. So I'm really going to focus on the left-hand side. What we feel is that when you evaluate a solution, some of the questions that you should be asking is, number 1, does this entity have paper process expertise? Do they know my industry, or are they just trying to sell me a solution that was developed in another industry? Okay, do they talk my language? Do they understand what I'm really dealing with day to day? That's number 1. Number 2 is, what are they providing me? Are they providing me a tool set, or are they actually providing me something that is happening on my machine today that I can't get today? Okay. Are they actually providing me with a virtual soft sensor? Number 3 is, when I talk about analytically robust, right? What I mean by that is paper making is a highly variable, continuous operation. That process is much different than something like discrete manufacturing, where all of the inputs are exactly the same, 24 hours a day, right? And the tools that have been developed in that environment are different than the tools that are needed in pulp and paper. So does the analytics reflect and are robust enough, again, to reflect the realities of the process? Number 4 is, okay, if you have a solution, how do I make sure that it's accurate and it's reliable at all times? Many approaches in the market, somebody sits down at a computer, a process engineer, may spend a couple weeks developing some models based on the conditions at that time. But then what happens? Something shifts on the machine. It could be the Furnish, parts wear, something else changes. Different shifts manage the machine differently, right? So if you develop a solution and that solution is static based on a certain set of conditions on day 1, but on day 30, those conditions change and your solution hasn't, well, then your approach is no longer accurate. You can no longer rely on that output. So you should ask yourselves is, how does this solution keep up with as my process changes, right? Number 5, again, what we're trying to do here is implement a solution that as closely reflects what's going on, not only at the machine, but down to those grades. And that's important because, as I mentioned before, you can have 2 machines that run side by side, but behave slightly differently. And so what you need is a solution that was developed, again, to how each individual machine runs and how and the different grades produced on that machine. If you try to just use a generic solution and apply it the same way, built the same way to everything that you produce, you're not going to maximize the productivity and the optimization. And then lastly, are they trying to sell you something different? Is it part of their core offering, right? How are you going to pay for it? But those are the things that we think are important that you ask yourself in evaluating how you're going to try to get to where you want to go. So with that, I'm going to turn it over to Tony Lewis. Tony's going to quickly go over some IT architecture slides and then get into the demonstration. Tony?
All right, thanks, Paul. Yeah, just really looking at a high-level view of the IT architecture, which a big component of this is security, because like Paul said, this is reliant on customer data, and being careful and protecting with that is the #1 priority. So we've got a pretty robust architecture that's built on top of Amazon Web Services. And then it addresses all of these things. So not only do we have multiple levels of security in there, we've also got the processes in place, as you can see, the interactions between what's going on at the plant historian, if we're doing autonomous control back to IoT controllers, Internet of Things controllers, and then also visualization and also controlling who's seeing the information. That's all configurable and controlled by the customer in concert with us. So pretty robust. And then you can kind of see on the right-hand side, the main components we have of OPTIX and all of the different engines and modules that exist in there. Things around closed loop autonomous, things we're developing around adverse event and root cause. And then of course the core prediction that everything's built around. So just kind of high level view. And like I said, the key takeaway is we've done a lot of due diligence on security. And as those conversations come up with how do we meet those requirements with a customer, we're pretty geared up to handle those conversations and address the issues. If you want to go on to the next slide, Paul. Well, here I'll take control, and what we're going to show you, like Paul said, is just a high-level overview of the application on our demo site. And let me steal this. And I'm assuming you guys can all see my screen now. And what we have here is the entry view once you log into your OPTIX site. We have the dashboard, and it's the first way to really kind of get access to the information. And this is a configurable space, so we can set what parameters show up here with the customer, and I'll walk you through how we do that. So the first step is obviously, like Paul said, prediction, right? Getting insights to quality in real time. So we obviously have the real-time prediction that this updates, and we've got a timestamp here every 30 seconds that we're recalculating. And then we've got all of the limits here configured just in line with the mill's operating parameters. So we're trying to mirror how they're trying to control quality. And then over here, we can show other predictions. So some sites we run multiple predictions. We may have wet and dry tensile. If it's a tissue machine, it can vary. But here we've got some components around how they're going to use the prediction and save money, because really that's the end goal, is to get some ROI out of this. So we have basis weight is obviously something that's important in the strength development in a packaging machine, and then also speed. So this kind of gives a high level overview of, okay, what's going on with regards to our real-time quality prediction and some KPIs we really care about that we're trying to influence. So here we can see, hey, we're a little on the high side with strength. We're kind of in target with basis weight. We're a little low on speed. You know, maybe this is an opportunity where we can optimize a little bit of weight, and we don't have to wait for that lab test. We can do that right now, and we'll be able to see, does that kind of help our strength kind of move in line? If we take a little weight off and we're steam limited, we can probably take advantage of that speed. So it's just really a quick way to kind of, for management and the folks running the mill, to kind of imprint digitally what their control strategy is, to kind of highlight it with the operators. You'll see up here, we've got machine state and the grade. Those are other important things. So much like Paul said with the subject matter expertise, we know that different grades are different for different reasons, whether it's operational or mechanical limitations, steam limitations, removal of water. All of that gets taken into to effect. So our models are grade specific, and then also knowing whether the machine's in a break state, down, all of that, we note that because we treat that data differently. So now we're going to jump into the prediction page, which is digging a little bit deeper. And depending on the mill, some mills stay and operate on the dashboard. Others kind of work on the this predict page. And really, all we're doing is taking the prediction and we're showing it in time series. So now you can see this is the point that is on display on the dashboard, and we're just looking at it over the last couple hours here. What we have obviously is the prediction, so we can see it's in the yellow. It's on the upper control limit side, so that changes colors in accordance with the specifications. We draw a mean line in there. Some have asked for that. We also show reference to target. So here we're giving a little strength away. Could be an opportunity. We also can overlay the measurements in there, but we'll show why that's more important, and that's mainly important for the machine learning component, and I'll explain that in a few minutes. There's no breaks here, but if there were, we would highlight them with a magenta area just to specify that the machine was in upset conditions, and then we've also got the specification limits. So just a quick way to kind of put the prediction in context of basic SPC and where the mill wants to run with quality. Again, the biggest thing, just like the dashboard, how people use this, I've got this number right now in my quality, I can make decisions and influence it. So just as we've probably seen, like Paul described, hey, I make a turn up, I test that paper, and then I've got to go make some decisions, and then I've got to wait. Here, I can make several moves in real time in that reel and get to optimization quicker, but also see those impacts, because I think, as we all know, some of the items individuals move may or may not be impactful. Here, the model can account for those and show that in real time. So it's real powerful. Here, I'll zoom in a little bit. This is not really utilized. It's mainly for the OPTIX team on the back end, but this is just evidence of how we're utilizing machine learning. So the green area is we're drawing a line in the middle point of our prediction confidence interval. So prediction is a probability. It's not just one number, but we draw a reference point. We also look at the measurement, and every time we get a measurement that comes in, we look at the algorithm looks at how well it did against that prediction. It also looks in context of all the other data coming in, and that's how it develops its confidence interval and how it continues to tune itself, and then also change what parameters go into the model. And this is the dynamic nature that just never ends, and this is truly the autonomous part. So individuals that have experience in tuning soft sensors, that's usually a manual intervention. Somebody has to review the data, look at all the coefficients, and retune the model. This just happens in real time based on the artificial intelligence, and it's always just trying to get the most accurate prediction it can and continues to search for the variables it needs to get there. So you'll see the confidence interval, what will happen is that will grow and shrink over time based on the level of stability, if there's any kind of deviations in testing. It's all just part of how the model's adaptive to those situations. We also have some higher level indexes here, which are more complicated for our data science team, and that's really to kind of let us know how the model's performing. And here we have an example, our prediction performance index, and what we say really is if that value is within these limits, our prediction's performing acceptable by standards. Now here you can see there's some deviations, and this is actually a really good example because these green boxes are grade changes that are happening. And as we know, sometimes there are very upset conditions. We handle them, and then sometimes there's an adjustment the model starts to make on itself. So here, there's obviously a grade or an upset condition that happened. and then the model starts to retune itself by evidence that it's getting back in its prediction performance index. And this was all done without human intervention. So this is the autonomous nature of it just tuning itself. We'll dig down to the next area. We can monitor all the variables on the back end, just as you would in your data historian from trending. But what's a little more important to go through is what is the model using and getting visibility to that. So we pull in about, on average, about 200 process tags or process variables, and we don't need all of the variables. And this is where we use subject matter expertise, and we marry that up with good data science practices. You don't need to have everything in there. It actually causes some confusion with some of the math. And then also you get a lot of redundancy in variables. So what we look at is a pretty good representative sample based on subject matter expertise around measured values and important parameters that we know in papermaking, all the way from the pulper to the reel. And we try and keep that in about 200. From there, the model, the artificial intelligence, it determines what it needs to use. So here we're only using about 6 items. I can tell you an hour ago, there was 30 items in here. It varies and it's dynamic in its nature. So we can see this just updated here at, in our time, 7:55. So this always changes. And then also the level of influence, the size of the bubble will change too. So we can see this parameter is more influential. They're all important for the prediction right now, but they have a different level of influence or telling it different things. And probably one of the hardest pieces for folks to understand is we're very used to looking at things one-dimensionally in that relationship of 1-to-1, much like Paul showed in that example, basis weight to strength. Here, these are very multi-dimensional, so it's very hard to understand why it's picking them. We just know it's using them, and we saw from the previous page, it's making an accurate prediction, and that's kind of, we kind of let it do its thing there. But here we see, hey, some things from a paper-making standpoint that make sense. Hey, basis weight's there. We know you add basis weight, you get strength. Hey, we know refining's in there. We know that's important. There's some other things that kind of can come up here, like vacuum. Okay, we don't really have a knob to turn vacuum, but we can influence it through things of furnish selection, how we refine, how we run our retention programs. We'll often see items on here around our water systems that come up that provide very important information for the predictions. So looking at the dynamic nature of this gives the first level of, hey, what's going on with my process and what is the data telling me? And this really is mainly utilized by process engineers and then the machine managers who want to start to kind of see what their data is doing. And it can be first level root cause. You know, if I knew some of these parameters I could change, like I could change basis weight or refining, I know these are high up and pretty influential in my prediction, I might want to go move those first, right? Digging deeper into this, and this is more for kind of the machine managers kind of really looking at their asset long-term, we can dig deeper into those insights. And I've pulled up a report here, which we can look at that influencer data over time series. So let's say we look at it over a couple weeks or 30 days, and we start to see what is our data telling us, and does that kind of match up with what our papermaking and perceptions see out there? Because there could be things that make sense and there could be things that don't make sense. So here the first, and I'll just take you through a few examples we have. Here is all of those influential variables. So just like that previous view I showed you, what's being selected over a time period, how many times it's selected. So here we've got, you know, probably 7 days we selected. So I'll just scroll through here. So this is all of the variables and how often they were selected to be important to the prediction. So here we can see weight control is notably seen as a big predictor, probably because, and this is a demo machine, but probably because the data says, hey, they move basis weight a lot to control strength. But here we can start to see some other things that pop up in we typically look at the top 10 list, And we see some interesting things around, base sheet conductivity. Hey, that's number 4, and that gets selected a lot. Does that tell us we should be paying more attention to our wet end chemistry, how we're kind of scavenging things with regards to conductivity? It could, and here right below it, we see the thickener cloudy leg. Hey, that's our short water loops. How are we cleaning our water and bringing it back to the machine? Fines management is a huge part of chemical programs and also strength. So we start to see a little bit of these things are important. Maybe these are areas we can focus on to weed out variability, or just understand them a little bit more in their relationships. Are we making decisions here that we don't think impact us? And they could. So that's one example of digging deeper to kind of potentially change how you control your machine using your data. One last one that's pretty powerful is we ask when we onboard a customer, how do you control strength if we're predicting strength? And we ask for what are the 5 to 7 levers or parameters that you're moving to kind of make this happen. And then we log these and show them. And this is basically a blueprint of what's the control strategy you're using for this parameter. And then we show you what the data is telling you. And we look at really 2 key things: the level of influence, and keep in mind, it's not really correlation because, like Paul said, right, the influence could be multidimensional, it could be bimodal, there could be a lot of different things here. But we kind of scale that into an index, and it's the level of influence. So obviously greater is, bigger bar is more influential. And then the coefficient of variation, which is really a relative index of standard deviation over the mean. And really that gives an indication of how often this parameter is moving, right? So let's look at the base refiner, right? It has, out of all of the parameters, the highest level of influence, and it has a high level of coefficient of variation. It's getting moved a lot, right? So that's something that we know we're moving and is in the grand scheme of things pretty influential, even a little more influential over than what we're doing weight. And then maybe it is because we don't move weight that much. But here, this starts to give us a very more narrow focus into what is our data really telling us about the things we're doing on the machine. Here with starch, it's not very influential, but we know starch is important, but it's probably because we never move it. Maybe this is something we want to think about making adjustments to, because maybe refining slows us down. Maybe there's a better mix between moving starch and refining that gives us a more optimum level. And this gives us the first look at what is our data telling us in real time, because that's the beauty of this. It's always being updated versus some of the old ad hoc analysis is once we pull a data set, that data set loses its reference because we've already moved beyond it. The process is already changing. So powerful tools, just to give you an overview of how we can start looking at your data deeper with regards to quality. Other things we have in there, you can see up here, there's activity log and notifications. So we have the ability to log items in here, felt changes, things around our chemical programs in here. And then also there's a notification level where, hey, if we wanted to just flag alerts how many times we're out of deviations for a predicted value, now that we have it in real time, we can set all that up and either email reports or text them over. But just a lot of functionality in there, but just giving you a high level overview. So I think, Paul, with that, I think that concludes the demo. I think we're going to jump back into the presentation. Yep, and now we're going to talk you through some use cases. So just building off a little more on what we talked about. So here is one in a tissue customer where we looked at strength. And, they were managing, this is kind of like Furnish impact, they were managing broke as a big component of their Furnish. And with having the real-time prediction, they could make a lot quicker adjustments to utilizing that broke and kind of get where they wanted to go. That sometimes they would make only a couple moves a day because there's so many other things changing on the machine. They're not really sure if their broke was being impactful negatively or positively. So here they were able to kind of manage that and increase their broke utilization by 13% in real time. this could very easily apply to a hardwood softwood kind of blend, Furnish optimization. And we know a few percentage points on some of these large machines, making those are a lot of return for customers. So being able to make those adjustments with a high level of confidence and see it is the way you kind of start optimizing and getting those dollars. If you go to the next one, Paul, here's just another one with strength, and looking at just basis weight optimization. On the top you can see, hey, there's their weight. They were able to move that down and have a very minimal impact on where their strength ran to target. And we see this often where, because we don't have the real-time visibility in the quality parameter, you run with some level of insurance premium. And when you look at any kind of parameter, people tend to run to what's the exception, because you need to buffer out what those pieces are. Well, now we can see those in real time and we can take advantage of them. And a 2% basis weight on any kind of machine is pretty impactful from fiber savings over when you annualize it. And here, this is the core principle. Again, tissue and strength. The whole goal is I'm going to make better decisions using that prediction versus my lab value. So as I make better decisions, I'm going to reduce that variation, right? And then, as we all know, once I make that reduction in variation, now I can shift closer to whatever mean I want, right? Whether it's my target mean or just where my operational mean to move at. And these are just examples of where we went with the strength. We see pretty significant reductions in that variation. It allows folks to move. Again, another packaging one, and this is kind of double fold for folks that run packaging machines. When you're able to utilize strength and kind of find those levels of optimization and weight, same thing. Hey, I can see strength. I can make a move on basis weight and know it's not really going to dump me below my lower specification limit. Machines that are steam limited, they're able to take advantage not only of the weight, but also of the speed and make more unit production. So they kind of get a double ROI effect. So a little bit of fiber optimization plus, moving out, 37 feet or handful of meters per minute is huge. Here's one more level, which leads into some of the autonomous control that Paul talked about with optimization of chemistry. On functional chemistry, this is a great example around wet strength. Now we can see that in real time. We can make better decisions and optimize, chemistry, make sure the right amount of chemistry is fed at the right amount of time. So here's actual numbers where we implemented OPTIX and made better decisions and moved from, you can see on the left, where we were using usage per ton, and then just kind of walked in a trial state, and then even further as we kind of further implemented OPTIX. This is a great, just back to that slide, this is where, Paul, where you referred to autonomous control, this is really a good entry point where, yes, you can have people manually do this, but these are the types of things now you can use autonomous control to kind of help do and kind of run in real time. A little bit on our implementation process. One of the key parameters is being able to deliver this quickly and efficiently to our customers. We don't really want this to drag out to be like a science project for multiple months, but we've got about a 10-week process when we get commitment and get the items we need, which really consist of a questionnaire, which is some information, some context around what you want to look at, why you want to look at that parameter. There's some IT specifications because we do need to establish connection to the historian. And then we need some historical data because we can take that data offline, and we do a couple things. We look at the health of that data and give a report back on that. There could be some parameters that just for data science reasons or modeling reasons, just they're not healthy, they're flatlined, they may be acting odd. And we provide that input back to the customer. And then we also do an offline validation and give a report and say, hey, we can predict with a pretty good level of confidence, and there's some other information in that model, in that report that comes back. And then from there, once we have the connection, it's about 4 to 6 weeks, we can kind of set up and deploy the environment. And then we go live, which is really working with the teams to get them to understand how to use it, what they're looking at, do a little training, and then off to implementation.
Great. Thank you, Tony.
Yep.
So, and I apologize, I'm getting back background. Hopefully you guys aren't. Is the great thing about what Solenis has done as it relates to developing and bringing this solution to market is you're supported by a dedicated team, not only within Solenis. And the great thing about the Solenis team, it is a makeup of all of the best skill sets in regards to commercialization. Most of the team here you see have run paper machines in the past. And so again, they come from the pulp and paper industry. We have our own data scientists to incorporate that expertise into what we do. But just as important is we've partnered with Process Miner. Process Miner is our technology partner. And that's just a great combination of marrying, as Tony said, domain expertise with the latest in data science. And again, not just data science in a general term, but data science applied to the uniqueness of what's going on in pulp and paper as it relates to multidimensionality, highly variable, continuous operations, right? That just inherently looks different than other types of manufacturing. So domain expertise, best artificial intelligence, but artificial intelligence developed and applied in the context of pulp and paper. And what does that allow us to do? And what is it again? It's not just a tool set, it's really a turnkey solution for operators, for process engineers, for mill management to fully optimize the paper making process. And doing that in an accurate, real-time environment, right? That accuracy is maintained through machine learning, real-time adaptation, and just better than any other tool set or approach. Again, because we are tailoring the tool to the needs of pulp and paper making, not trying to force a generic approach into pulp and paper. And again, as I mentioned on the onset, really allows us to do three things, right? Allows operator to make those real-time process adjustments instead of waiting 45 minutes and being in a bad environment for 45 minutes. Nobody wants to be in a bad situation for 45 minutes. If you have the ability to respond in 30 seconds, that's an advantage. Number two, Tony showed all of the reports to highlight influential and dominant variables and how they're behaving on the paper machine. Again, gives the right people more insight to understand what's going on in the process. And then number three, taking those to provide immediate process input optimization, whether it's chemistry, fiber, et cetera, to really get full productivity immediately without making it complex. So with that, Beth Ann, we'll start the Q&A session.
Absolutely. Thank you, Paul. Again, thank you everyone for attending. For more information, you can, or I'm sorry, let's not go there yet. Let's go to the Q&A session here. But if you do have a question, you can go ahead and unmute your line or go ahead and type your question in the chat window. Both of these things can be found. There's a little toolbar that will pop up on the lower part of your screen. And then there's a raise hand icon, a message icon, and one of those will work for you if you want to go ahead and ask a question. We do have some questions coming in. So this one looks like it will go out to Tony. So could this system be used for to predict complex parameters such as EMTEC hand feel values?
No, great question, and we've heard this often. So I think the first piece of this is hand feel isn't directly measured off of the reel. We measure a bunch of other things that kind of give us information, and then hand feel's kind of separate. But I think the key piece with this is a first step to beginning to understand at a new level to kind of get to that, right? So I would say out of the box is hand feel something we do? No, but I think we're in a lot of discussions with folks as to, Is it looking at other parameters that we can model there and start connecting those dots since we've got more granularity in the data? Because right now, just like Paul said, everything's pretty broken up by real. Now we can start to getting real machine direction profiles. So it's kind of a little bit of no right, not right out of the box, but yes, this is kind of where we want customers to be thinking about. Once we can model this data, how do we get to big complex opportunities like hand feel? We have similar ones in packaging where folks are saying, hey, can some of these, can I take this information and potentially bridge learnings in converting? All possibilities, right? It's just taking that first step of getting a better understanding visibility through machine learning on the data in the mill. I hope that answered your question.
Thanks, Tony. I'm going to piggyback on that one a little bit here. There was a question we received early on asking how we can use artificial intelligence to help with technical service and customer relationships, or the customer relationship department.
Yeah, so I mean, with customer relationships, I think here is the benefit of all digital tools, right? We're now connected digitally. So yes, OPTIX has a narrow focus, but now we can open that up to our network of specialists, our applications folks. We actually, even with some OPTIX applications, we do some ad hoc analysis work on very specific problems at those sites to kind of support them. And we don't have to fly people in. We can do that anywhere remotely in the world. And we're starting to do that more and more. So I think it's just the next way to connect all of the knowledge we have in Solenis with our customers just more efficiently. So it opens up a lot of doors for opportunity. And we're seeing that right now.
Perfect. Mamad had a question.
Yeah, I would like to thank my colleagues, Paul and Anthony, and you, Beth, for this really good opportunity to talk and explain about the OPTIX. I believe it is a novel technology, let me say, in order to help our customer to optimize the process. We know it is a challenging business, but it is good that we started with this technology. My question, in order also to make customers familiar with this technology, is the web version of the demo, OPTIX demo, available and accessible for everybody?
I think how we handle that, right, Paul, is if there's interest from a customer looking at it, they just work through their Solenis rep or their contact, and we can arrange access to that demo. Right, Paul? I think we've done that at other sites.
Yes. So Mahmoud, what I would suggest is, number one, as Beth Ann said, this recording, which 20 or so minutes of it was a demo, a customer can review that on their own. And then number two, as Tony said, is if we were just to do a one-on-one session to walk it through it a little bit more intimately with your customers, we can actually absolutely do that. So two ways. We leave it up to you to what approach, but we can cover it both ways.
Thanks. It's good.
Another question coming in, Tony, for you. So could OPTIX predict the impact of changing a couple of variables at the same time?
Yes. And this is a pretty important. Great example is a towel customer, right? Because yes, with wet strength, and I'll use this as an example, wet tensile, dry tensile is just as important. So on several towel machines, we look at both. Sometimes we look even up to 3 and 4 parameters. So it is possible. I think the only caveat is it is about focus, right? So it's making sure you've got the right combination that's driving your ROI and not just having multiple predictions for the sake of having them. So the example I used, folks really want to use that because they need to know, is it a base sheet issue that they're working at, or is it a chemistry issue? And that kind of gives them the both visibility. So that's how I would recommend doing it.
Perfect. So There was another previous question that was asked prior to the webinar, and wondering how AI or OPTIX may be able to help with product quality and planning.
I'm not sure. I guess I'll take my best stab at what they mean by planning. I'm assuming that means around kind of simulation or doing design of experiment, planning, trying to impact that parameter. Unless somebody chimes in, that's going to be my best interpretation around that. And it can be just for the use cases that we said, right? It's dynamic real time. So you can explore current areas that you're using, current variables, but also new ones. And then the model will learn from those.
And Tony, what I would do is I would just add on that. Obviously, from a quality perspective, we addressed that. Right now, we're giving operators and personnel the real-time ability to respond if things are trending away from target. Obviously, that has a direct impact on quality. And then the way that I would like to address also the planning is anytime you have a less variable machine, a more stable machine, and are running to target, obviously, that's just, you're going to have less surprises, right? And nobody wants surprises because surprises are hard to forecast, right? And then are hard to plan for. Anytime you can minimize that by running the process better, we'll just take that, minimize that part of the equation, and overall, your overall planning should just be better because your underlying process is better.
Yep, that's a good point.
Okay, thank you.
Can,
Sorry, go ahead.
yeah, can I ask a question, please?
Absolutely.
Yeah, can we use OPTIX technology to can get an indication for the hand feel in the final product to can optimize the addition of softener?
Yeah, so we covered that a little bit earlier. I think the challenge with hand feel is it's not predicted typically right off of the machine. We want to look at to start what parameters are directly off or tested on the machine. And then I think we'd have to engage in a dialogue with the customer and then figure out how do we connect those dots beyond into the hand feel test, because typically that can be tested in a panel test offline. So I think that's the key piece. I think there's some knowledge that can be learned from doing it. I think we just have to take it. It's going to be a more interactive approach with the OPTIX team and our local rep.
So what I would suggest is whoever asked that question, just please reach out to one of the three people that you see at the bottom of this screen, and then we can work with you specifically to discuss what is the approach. As Tony said, maybe there are some adjacent things we should look at first, get OPTIX running as both Solenis and the mill, uncover a little bit more insights. We'll see where that leads, but we'll be glad to have that conversation and map out where we would start and what that looks like.
Yeah, because some mills that do hand feel indicators, the TSA type testing on the reel, that is stuff that can be utilized because it's right at the point of testing at the product, versus some mills are not set up that way. So that's like Paul said, we just need to work through those nuances, but I think there's opportunity either way to kind of get learnings.
Okay.
Yeah, I have another question, Paul and Anthony. In tissue, one of the important rules of using the coating is to protect the Yankee. It is the heart of the tissue machine. Do we have something in OPTIX that cover this target, or we can develop something?
So those are more in our development pipeline. So we are working with our team and our applications folks to look at that that issue around asset protection. And it's a little different than quality, but I think it is something we are actively looking at. So
it would be really important and
Yes.
good added value for the customers if we have this.
Yeah.
I see that some customers are installing vibration systems that helps them to analyze and see what's the frequency and the for the vibration. But maybe with optics, if we also included the add-on of the chemicals or the sound of the coming from the coating and the harshness of the blade with the Yankee, maybe it will give some more benefits for this technology.
And that's exactly where the thought is, right? Because you're looking at, the vibration sensor it's another sensor, right? It gives you more information, but typically what happens with those is it's disconnected from the other process information, and then really trying to get to what's the root cause. And yes, we can adjust coding, and that's important, but sometimes the coding has limitations, and we really need to know, is it a process condition that's really driving that? And that's down what we're working towards in our root cause and adverse event modules. So those are to come, but we're actively working on those types of problems to solve those problems.
Fantastic.
Okay, thank you.
Thank you, Tony. Thank you, Paul. So again, thank you everyone for attending. For more information, and if you have additional questions, you can reach out to your local Solenis rep or Paul, Tony, or myself. You can also find additional information such as case studies and technical papers at solenis.com/optics. And following this presentation, you will receive an email with a link to the recording and a short survey. We ask that you complete the survey so that we can continue to provide you webinars that are interesting and have content that's relevant. Also, mark your calendars for August 12th at 9 a.m. Eastern Daylight Time for our second optics series, Papermaking Industry 4.0, gain more insight from the data you already have, which will be led by our resident data scientist, Sydney Recton. Again, thank you all for attending, and I hope you all have a very good day.
Thank you.